Hey, my name's Peter. Welcome to 8 Bits in the Basement. So, last week, what I did was I showed you the innards of this. It is a ZX Spectrum clone that I built about 2 years ago. It is a Leningrad, which is in fact a Russian Spectrum clone. So, as I explained in the last episode, there's an awful lot of these Russian clones around, and nowadays they make for a great little project that you can build up and try out yourself. So I explained a little bit of the insides of the board, the history of this particular system and my history with this particular system. And what I'd like to do in today's episode, which will be kind of the final part on this whole thing, is I would like to show you it working. So what we'll do is we'll just run it through its paces with a couple of Spectrum test programs, and also we'll see it play a few games, and there are many games that you wouldn't even realize that it was a clone. There's other games, however, that you would, and we'll go through those and I'll point out some of that kind of stuff, and we'll just in general put it through its paces and see what it can do. So I'll plug it into this TV and we'll get to it. Leningrad itself, the way it's made up, it's got a red, green, blue sync output to the television set. So what I did was I made up a little SCART cable and I've plugged it into the SCART socket on the TV and connected it in here to Leningrad itself. So all I need to do is to apply 5 volts and the system should turn on and give me a picture on screen. Now, as you can see, this is the picture I'm presented with at first, and it's not ideally what a Spectrum would give you, but the reason for it is it's down to this system uniquely, and it's the way I've built it, I think, because there's a little bit of voltage drop on it, and what's happening is generally a Z80 processor powers on, it needs to be reset, and then it starts working correctly. What's happening here is it powers on with not enough power because of the voltage drop. It gets reset, but it still doesn't have enough power, so it kind of hangs in this position. Now, the board here takes about 30 seconds to build up power enough, and once I reset it again, it'll start up normally as it should. So I'll hit the reset button here at the back, and there we go. I'll just put the screen to the 4:3 aspect ratio. There we go. Now, so as you can see, once it has started up, it started up as a Spectrum would. So we're presented with our little copyright 1982 Sinclair Research Limited screen. Now, it behaves in all ways pretty much like a Spectrum when you're programming the system. So for example, just to show a few quick little ones, if I press B to give the border command and I type 4, which is for green, it'll change the screen or this border around the screen to green. I can do the same, making it magenta with 3, making it white again with 7. I can make it black with 0. And so it pretty much works as a Spectrum would work. Now, just to show you the programming end of things on this, for example, we do a quick hello world program just to show. So it's quick enough to enter commands. So I type my 10 for the first line, P gives me the print command, symbol shift and P opens my inverted commas. I'll do a hello world, and again I have the choice between uppercase and lowercase letters by pressing cap shift, O, R, L and D, and symbol shift and P again closes the inverted commas. 20, G for go to, 10, and R will give me a run, and I hit enter. So here you can see it works as a Spectrum does. It scrolls 22 lines and asks me, do I wish to continue scrolling? And until I hit any key other than break, which is also the space key, this will continue on this way. So if we break out of that, I can list my program by pressing K, get the list command, and there we are with my my hello world little program that I wrote. Okay, so I'll tap in another program just to show you this running in another way. So 10 for I equals 1 to 1000. 20 print I. 30 next I. And 40 go to 20. So we run that, and it'll run down the screen down to 1000 and stop every 22 lines asking me if I wish to scroll on. So that's all well and good, but I'll show you one little thing that I noticed. Now, I don't have a spectrum to verify this, so I don't know if it's the case or not, but if I change line 10 to for I equals 1 to 100, for example, and now I run that program, you'll see that it's doing the same thing again. It goes down to 22, down to 44, and I keep scrolling on. Now it should stop at 100. That's what happens on most other systems. But here it keeps on going. Keeps on going. So I don't know, is that something unique to this Leningrad or to the Spectrum? I don't have a Spectrum I can verify it on, and I've never heard any talk of it. So I just said I'd show it. I'd throw it in there, just in case. Okay, so what I've got here now that I'd like to run is a little suite of test programs that's usually used for the Spectrum 16K, 48K, or the Spectrum Plus. But I thought it'd be a nice idea just to run it on the Leningrad to see how this clone system compares to a Spectrum, to a real Spectrum. So I'm using my Maxduino here to load up any software that I'll be shown, and it loads pretty much, well, in fact, exactly the same way as a Spectrum. We type J to give us our load command, and symbol shift and P twice to give us our inverted commas. We press enter, and then we press play on tape, and we get our loading bars, and it should find the program and then carry on loading from there. So here we go. It'll take about a minute or so. Now, so here we are. This guy's after loading up. It took about 48 seconds or so. So it was written in 1985 by Dr. Ian Logan, who I assume was a PhD in computer science. But it covers a couple of basic tests that are kind of essential to check that bits and pieces in a Spectrum are working properly. So we'll start with our keyboard test. And what it does is each time I press a key, you'll hear it gives a little beep, and it also puts a little red dot over the key that I've pressed. So we can quite easily check that all the keys are working. There we go. And that was invaluable actually when I was testing out the keyboard on this, trying to get it wired up to work properly, but that came in handy. We have a color flash test as well. So what that does is it shows us a flashing bar here on the bottom, which means that the flashing text or whatever is working right. We can also see our 8 colors, or white, yellow, cyan, green, and all the rest. And it shows the 2 shades. You've got a light shade and a darker shade of each color. So that appears to be working correctly. The sound test is another one. We start that. And we can hear that the speaker inside in the system is working properly, but not only that, all the electronics and all the control sound and the generate sound are obviously working also. So we'll say that has worked. The next one is the one that is interesting for us, because the Spectrum had a ULA that was built by Ferranti. This guy doesn't. It's using TTL logic chips, as I explained in the first part of this guy. And because of that, it's emulating. It's not really, it's emulating, it's mimicking the ULA. So to see how well that performs, we'll run that test. Now, so according to this, it's passed the ULA test. Now, I don't know how thorough these tests are. They're kind of fast, but I imagine that on some level at least, this guy is performing exactly as a Spectrum 48K would. And the final one that interests us here, because we know that the cassette works, it's loaded up this, is the RAM and ROM tests. The RAM that we're running, we've got actually 64 kilobytes of RAM in here. 8 kilobytes chips, 8 kilobyte chips, and the system is actually only using 48K of that to maintain compatibility. So the other thing that we have is we have our 16 kilobyte ROM chip inside, only it's not just one 16 kilobyte, it's stitched across two 8 kilobyte chips. So we'll run those tests and see that all that is performing pretty much the way it should. So there we go. So it fills up the memory with whatever data and then it reads it back. And here we go. It says that it's passed the test. This Spectrum has 48K of memory in working order. Is this correct? And well, it is. So it's after passing all those tests. There is one other test that I ran on this system when first I got it working, and I will run it now again just to show you. Okay, so this guy here is called ZX Diagnostics, and it's a little test that tests both the ROM and RAM much more thoroughly than the last program I showed you. Once I had built the system and gotten it working properly, I let this guy run overnight to be sure that the memory inside the system was good. So here you see once it's loaded up initially, the first thing it does is it checks the 16 kilobyte lower RAM, and then we can run a soak test, which checks the ROM and runs through a number of different ROM tests and gives a pass or a fail, and then runs through them again. And it keeps doing this over and over again until you reset the computer. So this is a handy little one to be sure that the memory inside in the computer at least is good and working. Okay, so what I'll do is I load up a couple of games here just to give you an idea of what the system looks like when it runs. So we start off with Dizzy, and at load again is J for load command and our inverted commas, and press play. Now, there we go. So that's after loading up. It took about 4 minutes and 50 seconds. I can't actually use the joystick port that I used for this with this particular game because it'll only work with keyboard or Kempston joystick. And this guy I've only managed to configure with a Sinclair joystick. So I'll show you that in a minute. But for the moment, here's our Dizzy game. We can play it the same as you would on a regular ZX Spectrum. You'll see that the color clash is exactly the same on this system as it is on the ZX Spectrum itself. When I pass in front of something, my color changes as well. As you can see here, when I pass in front of the red, Dizzy becomes red as well. So yeah, that's working pretty much exactly the same as the Spectrum. This is one of those games that I don't think you would be able to tell that it was running on a cloned system as opposed to a real Spectrum. So that's pretty much it. It's just got left, right, jump, and then it's got a button to drop and pick up various different bits and pieces that you find around the game world. Okay. So here we go. You can see some little incompatibility issues with this game. You see all these bars around the screen, and but that's really the only thing that's shown up funny on it. Otherwise, all the keys and stuff are working the way they should. We can control the little man there on the screen. He turns into a werewolf as he should. He turns back into a little man again as he should, and yeah, this is pretty much it. This works as it should. We die as we should and all the rest. So that's little Saber Wolf, and that works fairly well. But like I say, any of the incompatibility issues apart from the game not working flat out, it'll be seen in the border around the screen like this. So Cauldron's after loading up first, and this is a game that I can use this joystick on. So I need to select my Sinclair 2 joystick and 4 to play the game. And here we go. We should be in business on this. Now, so as you can see, for certain games where I'm allowed to pick a Sinclair joystick or where I'm allowed to redefine the keys, I can use this joystick because I've mapped this joystick as a Sinclair joystick would be mapped, and that's to keys 6, 7, 8, 9 and 0 for the up, down, left, right and fire, and that lets me control whatever games I can map joysticks for. But there you go. This one is pretty much 100% compatible with the system. It works away absolutely fine. There's no problem whatsoever with compatibility on this particular game, and we can die just as easily on this as we can on a regular Spectrum. Now, so here's R-Type for the Spectrum, and luckily it works on the Leningrad as well because it's a fantastic little game, and I can use the joystick for it also because I can select the keys that I wish to use. So enter the select keys, and for left I go left, right, up, down. Fire will be this, and to detach we'll use space. So there we go. And now fire to play. So as you can see, it works exactly as it does on the Spectrum. It's nice and fast and fluid, and it's a fantastic little game as R-Type. But it really shows off. It showed off the Spectrum for what it was worth, and it shows that this little Leningrad clone is in its own right a great little computer. So yeah, that pretty much shows that. Oops, my head. There we go. There we go, and detach with space, and away we go. So yeah, that's R-Type for this system. Now, as I say, this little clone is fantastic. It's a fantastic little computer. It was a great little project to build, and it is pretty much compatible with 48K Spectrum. I say pretty much because of all the software I've tried to run on this, 95% of it, just by hazard picking a game here and there, has ran on it. You saw like with Saber Wolf, there's times that around the screen they'll show funny little patterns or funny little symbols and stuff like that. There are games that flat out will not work, but they're far and few between. There are other games like Bubble Bobble, for example, that has graphical glitches on screen when you try to shoot bubbles and stuff. The bubbles aren't bubbles, they come out and they glitch everything on the screen, but other than that it's kind of playable. My next plan for this particular system is I would like to put in an AY sound chip like the Spectrum 128, the +2 and +3 have, and also the Amstrad 464. Yeah, so I'd like to put in one of those, and I'd like to upgrade also the memory to 128K. So I will order the parts to do that, and I should have videos out just showing my progress and whatever in the new year, hopefully. Apart from that, there is a huge demo scene still for Spectrum computers in Russia, and there are hundreds if not thousands of demos have been written to show off the older Spectrums and also the newer clone Spectrums that are much more powerful. Now, what I'm going to do just to play out this video, because it's pretty much finished now. This is all I have to show you on this. Is I will play one of those demos. Now, there's no sound with it. There's no anything like that. It'll give you an idea of what it's capable of, and I'll probably put a little music track in behind. But there you go. So look, if you enjoyed this video, like if you wish to like, dislike if you didn't like it. It'd be great if you subscribe, but equally don't feel obliged. And a comment is always welcome. I try to answer any comments that are left for me. So look, thanks very much for watching. Between this and the next video, take good care of yourselves, look after everyone close to you, and we'll talk to you in the next one. Bye bye.